This videotape deals with solving quadratic equations by factoring. We have already developed methods for solving first-degree equations in one variable. A first-degree equation in one variable will be something like this. ax plus b equals 0. A and b are real numbers. X is not equal to 0. A is not equal to 0. This is a first-degree equation in one variable. Our technique for solving this equation would be to isolate x. In this case, we could subtract b from both sides. We try to isolate x, divide both sides of the equation by a, and we would have x equals minus b over a. You isolate the variable x, and that's how we solve a first-degree equation in one variable. Now, many practical problems give rise not to first-degree equations in one variable, but rather second-degree equations in one variable. Such equations are known as quadratic equations. A quadratic equation is one that can be put into this form: ax squared plus bx plus c equals 0. A, b, and c here are real numbers. A is not equal to 0. This is a second-degree equation in one variable. This is second-degree equation in one variable. And we will call such an equation a quadratic equation. A first-degree equation in one variable is also known as a linear equation. Okay, now the key to solving quadratic equations by factoring is the fact that we have the number 0 over here. The number 0 has a very special property. If the product of two numbers is equal to 0, then for sure at least one of the two numbers has to be equal to 0. This would not be true, for example, if the product of two numbers is 18. Well, one could be 9, one could be 2. One could be 6, one could be 3. You don't know anything definitely. But if the product of two numbers is equal to 0, then for sure at least one of the two numbers has to be equal to 0. Let's write this down in symbols. Okay, if the product of two numbers equals 0, if a, b equals 0, once again, a and b here are real numbers, then either a equals 0 or b equals 0, or both. Okay, this either a equals 0 or b equals 0, okay, allows the possibility that both are equal to 0. It says, okay, if the product of two numbers is equal to 0, then at least one of the numbers is equal to 0. And what we're going to do is we're going to take our quadratic equation, or equation of the form ax squared plus bx plus c equals 0, and we're going to try to factor, okay? We're going to factor this trinomial if possible. Now, it may or may not factor over the integers. Okay, we're going to try to factor this trinomial. If we can do that, we will have this as the product of two numbers equals 0. Okay, then we will be able to say that at least one or possibly both of these numbers equal to 0. We can set each of the numbers equal to 0. What's going to happen is that this is going to reduce to two first-degree equations in one variable, which we already know how to solve. Okay, let's try an example. Okay, x squared minus 5x plus 6 equals 0. Here we have a quadratic equation in standard form. Standard form means you have it ax squared plus bx plus c equals 0. It's very important. Everything is on one side. The right-hand side here is 0. Okay, we're going to factor this trinomial. That's very easy to do. First of all, we notice that the lead coefficient here is 1. The coefficient of x squared is 1. Okay, so we can just say we're looking for two numbers which multiply to 6 and add to minus 5. And the answer, of course, would be minus 2 and minus 3. Okay, minus 2 and minus 3 multiply to plus 6 and add to minus 5. Now, checking our factoring by the FOIL method, we get x squared minus 3x minus 2x. That's the minus 5x, and then the plus 6. So we have factored this. Okay, what we have done is to put this in the form a, b equals 0. Okay, the product of two numbers is equal to 0. Remember, x is a number. Okay, so x minus 3 is just another number. We have one number times another number. The product of two numbers is equal to 0. Okay, this gives us two possibilities. A equals 0 or B equals 0. Two possibilities. The product of two numbers is equal to 0, so we could have either of the numbers equal to 0. And as I mentioned before, this gives rise to two first-degree equations in one variable. Okay, solving the one on the left, we would have to add 2 to both sides, and we would get x equals 2. And solving the one on the right, adding 3 to both sides, we get x equals 3. We have here two solutions to the quadratic equation, and we're going to check these. Okay? To check, we go back to the original equation. Okay, x squared minus 5x plus 6 equals 0. If we have found the solution, then when we substitute this value into the original equation, we should get a true statement. So let's try that. We're checking x squared minus 5x plus 6 equals 0 with x equals 2. So we get 2 squared minus 5 times 2 plus 6 should be equal to 0. That's 4, 2 squared minus 10 plus 6 should be equal to 0. And what we have here is 4 plus 6, 10 minus 10, 0 on the left equals 0 on the right. It checks out. So x equals 2 is certainly a solution to the equation. Let's look over here at x equals 3. Once again, substituting into the original equation, we get 3 squared minus 5 times 3 plus 6 should be equal to 0. 9 minus 15 plus 6 should be equal to 0. 9 and 6, that's 15 minus 15, 0 equals 0, and it checks out. Okay, so we have solved this quadratic equation, okay, by factoring. We must first start, however, with a quadratic equation, what we call standard form. Okay, everything on one side equals 0. Okay, then you can use this technique of factoring, assuming you can factor this trinomial. Then you factor it, set the product equal to 0. We have the product equal to 0. If the product of two numbers is equal to 0, then at least one of the numbers is equal to 0. We set this number equal to 0, this number equal to 0, and we get the two solutions to the quadratic equation. Okay, let's try another example. Okay, x squared minus 6x equals 0. Okay, once again, we have a quadratic equation. It's in the form ax squared plus bx plus c equals 0, except c is equal to 0. The constant is equal to 0. That's perfectly okay. The only rule that we have is that a not be equal to 0, because if a were equal to 0, there would be no x squared term, and it wouldn't be a quadratic equation. Okay, but we have quadratic equation in standard form. The right-hand side is equal to 0. We try to factor the left-hand side. It's a very simple one to factor because it has a greatest common factor. In any factoring problem, you're always on the lookout for a greatest common factor, some common factor that you can pull out from the terms here. And here you can pull x out. Okay? Pulling x out, we get x squared minus 6x equals 0, which is what we want. We now have the product of two numbers equals 0. This is like a, b equals 0. This gives rise to either x equals 0 or x minus 6 equals 0. A, b equals 0, so a equals 0 or b equals 0. Okay, now the one on the left, of course, is already solved. X equals 0. The one on the right, we add 6 to both sides, and we get x equals 6. Okay, so two solutions to this quadratic equation. X equals 0 and x equals 6, and you can check them very simply. Okay, we're checking in the original equation, x squared minus 6x equals 0, substituting in x equals 0. 0 squared minus 6 times 0 should be equal to 0. This is 0 minus 0 should be equal to 0, and of course 0 equals 0. And when you substitute in x equals 6, you get 6 squared minus 6 times 6 should be equal to 0. 36 minus 36 should be equal to 0, and that checks out as well. Okay, two solutions to this quadratic equation. Okay, I don't want you to feel that all quadratic equations will always have two solutions. One thing we can know for sure is that they will not have more than two real solutions. Okay, the examples that I've given you so far they've had two real solutions. Let me show you a quadratic equation that has only one solution, x squared equals 0. There is only one solution. This is in the form, this can be thought of as, say, x times x equals 0, ab equals 0, giving rise to x equals 0 and x equals 0. Whereas there is only one solution. Okay, if you want to think of it in the form that we had before, it's like ab equals 0, a equals 0, or b equals 0, but of course these are the same. So there's only one solution, x equals 0. It's a quadratic equation, okay, with one real solution. You can also have a situation, a quadratic equation has no solutions, no real solutions. X squared equals minus 4. Okay, it's a quadratic equation. It can be put in the form x squared plus 4 equals 0, which is, you're missing the bx term, but it's still a quadratic equation. And it has no real solutions. There's no x value that you can substitute in here and make this come out a true statement. Because if x were positive, squared, it could not be negative. If x were negative squared, it would also be positive. Positive squared is positive, not negative. Negative squared is also positive, so it can't be minus 4. And 0 squared is 0. So no matter what value you'd substitute in for x, it couldn't possibly, when you square it, give you minus 4. Okay, so this has no real solutions. Okay, this has one solution. Okay, but what you can say about a quadratic equation is that it cannot have more than two real solutions. Very often you will get the two solutions. In fact, most of the time in our problems we will be getting the two solutions. Okay, I want to look at this problem that we just handled before. I want to look at it again. I want to show you the wrong way to solve this. Okay, x squared minus 6x equals 0. You've seen the correct way. You factor, and you set each factor equal to 0. Okay, the wrong way to do this, and a lot of students like the wrong way. Okay, wrong way. Okay, they have x squared minus 6x equals 0. They add 6x to both sides. They get this. Then they divide both sides by x. They say x squared over x is x. 6x over x is 6. And they get one solution. Okay? You only get one solution this way. Now, what is the problem? Okay, it was perfectly okay to add 6x to both sides. The problem was dividing by x. When you divide by x, you have to assume that x is not equal to 0. Now, in this particular problem, there was nothing wrong with x equaling 0. It was a perfect, in fact, it turned out to be the other solution. Okay, so when you divided by x, you assumed that x was not equal to 0, which means you cut off the possibility that x was equal to 0. You lost a solution to the equation. Okay, so don't do it this way. It's going to be very important, okay, later on in mathematics to make sure you get all solutions to the equation. Okay, so it's very important that you don't skip one. If you solve this problem by the wrong way, you will get one of the solutions, but you won't get both. This is the wrong way to do it. You're supposed to get everything on one side equal to 0, factor, then set each of the factors equal to 0. Not this way. Okay, let's look at another example. X squared minus 3x equals 10. Okay, where some people make mistakes in this example is that they immediately start factoring. They say, well, x squared minus 3x is x times x minus 3. What they've ignored, of course, is the fact that you have 10 on the right-hand side, not 0. There's nothing special about the number 10. If I were to factor this, x times x minus 3 equals 10, I really couldn't proceed from there. I'd have the product of two numbers equals 10. Well, that's terrific, but that doesn't tell me anything about the numbers. Okay, one could be 5, one could be 2, one could be 20, one could be a half. If the product of two numbers is 10, it doesn't tell me anything definite about the numbers. If the product of two numbers is equal to 0, then I know for sure at least one of the numbers has to be 0. Okay, so what we want, of course, is to put this into standard form, to subtract 10 from both sides of the equation, giving us x squared minus 3x minus 10 equals 0, and then we can start the problem. We now have a quadratic equation in standard form. Okay, we tried to factor this. First thing we notice, of course, that there is no common factor here. We have a trinomial, and there is no common factor. We're going to try to factor let's see, the lead coefficient is 1, the coefficient of x squared is 1, so we're looking for two numbers, the product being minus 10 and the sum minus 3. Okay, well the numbers are minus 5 and plus 2. Minus 5 and plus 2 have the property that they multiply to minus 10 and they add to minus 3. Checking our factoring by the FOIL method, you get x squared plus 2x minus 5x, that's minus 3x minus 10. We now have this in the form, the product of two numbers is equal to 0, and we let x minus 5 equal 0 and x plus 2 equals 0, and we get here adding 5 to both sides. Okay, x equals 5. Here, subtracting 2 from both sides, x equals minus 2. Two solutions, once again. And you should check them both. In the original equation, go back to the x squared minus 3x equals 10. Okay, now it's possible that you've made a mistake, for example, going from the first step to the second step. So don't use this equation. Go back always to the original equation, the one that you were given. Okay, and you substitute in x equals 5, you get 5 squared minus 3 times 5 should be equal to 10. 25 minus 15 should be equal to 10. And of course, that checks out. 10 equals 10. And similarly, when you substitute in x equals minus 2, you get minus 2 squared minus 3 times minus 2 should be equal to 10. Minus 2 squared, that's 4. Minus 3 times minus 2, that's plus 6. Should be equal to 10, and 10 equals 10. It checks out once again. So always go back to the original equation and check your solutions. Okay, let's try another example. X plus 5 times x minus 4 equals 10. Okay, somebody looking at this might say, oh, terrific, this one's already factored. But actually, not only isn't it helpful to you in this form, it's really set up to trick you. What you have, once again, is the product of two numbers equals 10, and that's not good for you. What you need is the product of two numbers equals 0. So what you first have to do is use the FOIL method to multiply these two binomials, then to subtract 10 from both sides, and then and only then can you really start the problem. Okay? Don't fall into the trap. You can't say, well, one is 10 and one is 1, or 1 is 5 and 1 is 2. You don't know anything. If the product of two numbers is equal to 10, you don't know anything definitely. So let's multiply out the left-hand side. We get x squared minus 4x plus 5x, that's plus 1x, minus 20 equals 10. X squared plus x minus 20 equals 10. Then subtracting 10 from both sides to put the equation into standard form, we get x squared plus x minus 30 equals 0. And we're going to factor this. The lead coefficient is 1, so we're looking for two numbers which multiply to minus 30 and add to plus 1. Okay, 6 and minus 5 will do it for us. They multiply to the minus 30 and they add to plus 1. So when you check it by FOIL, you get x squared minus 5x plus 6x, that's plus 1x minus 30. Okay, equals 0. Now, we have the product of two numbers equal to 0. We set each of the numbers equal to 0. And we get the two solutions. Subtracting 6 from both sides, we get x equals minus 6. And here, adding 5 to both sides, we get x equals plus 5. And we should really check these two. I'm not going to go through the check for you, but you should go back to the original equation. Once again, not the multiplied out form, because you could have made a mistake in multiplying it out. Okay, back to the original equation. You substitute in the minus 6, and without actually going through the work, you would get minus 6 plus 4. That's minus 1 times minus 10, which gives you the 10. And when you substitute in the 5, you get 10 times 1, which also works out. But you should actually check each of your solutions. Okay, let's try another example. 1 plus 1 over x squared equals 2 over x. Okay, here we have a fractional equation. Okay, we know our procedure with fractional equations is always to find the lowest common denominator, to multiply both sides of the equation by the lowest common denominator, because in doing that we will eliminate all fractions, then we'll have a regular equation to worry about. And when we do that in this case, this gives rise to a quadratic equation, okay, which we're going to then solve by the factoring method. Okay, now in this particular example, we have here three denominators in a sense. In other words, it's 1 over 1 plus 1 over x squared is 2 over x. The lowest common denominator, okay, is found by taking each factor the largest number of times it appears in any one denominator. We have here 1. Here we have x times x. Here we have x. So we're going to have x squared as our lowest common denominator. That is the smallest quantity, okay, so that all of these denominators divide evenly into it. We will multiply both sides of the equation by x squared. Okay, now, there is, in this example, a slight problem. Well, we have to make sure that x can't be 0. When we're multiplying both sides by x squared, we're assuming in this case that x is not equal to 0, because if x were equal to 0, we would have division by 0. Okay, this is something that we run into in any fractional equation. Okay, when there are variables in the denominator and your lowest common denominator involves variables, when you multiply by a quantity that could be 0, you run the risk of introducing solutions that aren't really solutions to the original problem. Okay, so the way around that is to always check, to always make sure you've actually performed a check on any fractional equation. Okay, in this particular example, we're going to multiply both sides by x squared. Multiply both sides of the equation by x squared. Remembering the distributive law, x squared times 1 gives you x squared. X squared times 1 over x squared, the x squareds cancel, gives you just 1. And here, 2 over x times x squared, x goes into x squared and leaves you with x. The right-hand side is 2x. You get x squared plus 1 is equal to 2x. You've multiplied each term by the x squared. Okay, we don't try to solve it in this form. We first subtract 2x from both sides of the equation, giving us x squared minus 2x plus 1 equals 0. We now have a quadratic equation in standard form, and we're going to solve that by the method of factoring. X squared minus 2x plus 1 equals 0. Okay, we want two numbers which multiply to 1 and add to minus 2, and the answers are minus 1 and minus 1. Checking by FOIL, we get x squared minus x minus 2x plus 1. This gives, if the product of two numbers is equal to 0, then either of the numbers could be equal to 0. Adding 1 to both sides gives you x equals 1. And of course, here also, you get the same solution. So in this particular example, we have only one solution, namely x equals 1. And we're going to check by going back to the original equation. 1 plus 1 over x squared equals 2 over x. Going back to the original equation, substituting the value x equals 1 for x, we have 1 plus 1 over 1 squared should be equal to 2 over 1. Here we have 1 plus 1 should be equal to 2. And of course, 2 equals 2. And it checks out. So x equals 1 is the solution. Okay, now I don't want you to feel that if a quadratic equation cannot be factored over the integers, then it has no solutions. Okay, in the next few videotapes, it may very well, by the way, it may very well have two real solutions, even if you can't factor it. In the next few videotapes, we'll be learning other methods for solving quadratic equations. Okay, this is the end of the tape.